Alright, hello and welcome. Tonight we're going to do something a little different. I was going to complete the JBL 8400 amplifier, and turns out I'm missing some parts, so I canceled that, and we're going to finish up another project since the parts are in. We're going to repair a Lego Rcx Pcb. So let's get into it. This PCB is not mine. I met someone at a Lego convention, actually Brick Fair, in Virginia this year, and one of their RCX modules decided to stop working. So, I've worked on some of these things like this before, and I told them I'd take a look at it. So we're gonna go over what happened and how to fix it. This is a pretty easy repair, as long as you have the tools. But the first thing I noticed, they mainly run this module off the AC power, and I can see that the caps are starting to swell. One of them is split on the top. You can see it under the microscope. You can't see it really good here. But the caps are bulging at the top. And even the camera doesn't pick it up real good. You can kind of see this one. But they're also leaking. You can see that some of the electrolyte is leaked here on the board, and it ran down and leaked here, and also these two buttons weren't working, so that's part of the reason. And let's see if I can get in here real tight, and we'll cheat a little bit and see if we can use some optics. So these pads right here, let's get a little more light. You can see that the pads down there are kind of gnarly and gross, and that's because electrolyte is conductive and it's causing those pads to short out. So we have some corrosion in different spots on here. Mainly by the buttons there. There's some corrosion. There's a pad right there that's a little whacked out. So we're going to clean that up. Replace the caps. I ordered some caps. And see if we can bring this thing back to life. So let's get to it. I'll show everybody the caps that I'm using. It's very important that you use the same size or the cover won't fit back on. So amongst my mess of parts here, I have too many open projects that I'm not getting done. I need to start finishing some of these things. But unfortunately, that requires me to have all the parts, and I'm constantly running out of parts, and parts are getting harder to find. So that doesn't help, but I was able to get the parts for this. And I ordered some extras just in case I get some more of these to work on, or go on eBay and buy some broken ones for myself. So these are the caps that I used. Hopefully anybody that's attempting to do this can see that. They are 30 or 330 microfarad and 25 volts. And I wish they weren't 25 volts because I have every other voltage except for 25, but now I have some of these. So I'm going to heat up the solder sucker and get ready. And this guy here is a 100 UF and 16 volt surface mount. So we're going to replace the can too. These still do leak. They generally have a longer life than the through-hole types, but just to be safe, we're going to pull it out. It's not worth the 37 cents or whatever it is to risk it. And these are fairly complex little boards for their age. This is what, 1998, so it's got some years on it, but it should be fine once we replace that. And getting these apart is pretty easy. There's some guides and videos online. I didn't really feel it was necessary to go through how to open these up and take them apart, but cleaning the board and replacing the caps is more valuable information, I feel. So we need to do a little bit of testing to make sure that the traces are still functioning through the board. So you can see while my iron's heating up, even on the back side. Right in there. I need my light again. Now you can kind of see it. It's that guy right there. It looks kind of gnarly and burned out a little bit. So we need to make sure that there's contact going through the board. If not, we're going to have to recreate that contact. So let's get to it. I'm going to pull the caps off first, then I'm going to clean the board, see where we're at, and then put the new ones back on. It really helps if you have a solder sucker. If you don't have a solder sucker, like, I would caution from doing it, just because you're working on an old board, more than likely made in China, with plenty of corrosion on it. Where were these made? I wonder if do they say on there? Maybe not. Maybe these might have been made at the Lego facility. But we want to clean out the old holes as best we can. You know, make sure there's any if there's any electrolyte on there, we're getting that off too. And you know, it could also be caused from corroded batteries too. If you know, you put it away for a few years and the batteries are left in there and the batteries corrode, that can, depending on which way it's sitting, the batteries can leak inside here and cause some damage too. Luckily this one's not too bad. As long as there's nothing else wrong with it either. I mean, this will essentially be like brand new, like day one. And we're definitely using higher quality caps. And actually, I'm surprised. So Lego actually spec'd Nichicon caps in there, so they used a tier 1 cap. I didn't even look at that previously. I'm impressed. You don't see that very often. But even the tier 1 and high quality caps have an age to them, and they're about at that age where they need to be replaced. I could not find this original size in Nichicon. But I did find them in Rubicon, so that's also a tier 1 supplier. So we're taking good ones out and putting good ones back in, so there's no need to worry about that. One more and then the surface mount. And I know there's a lot of videos out there saying that you can just twist these off and tear them off. Don't do it. Especially on, you know, older stuff. You risk damaging the board. Spend the extra 30 seconds and remove them the right way. So old caps are out. And to get the surface mount on, if you have surface mount tweezers, you can use them. I find they're generally harder to work with on caps. So I like to just use my regular iron tip and just remove them one pad at a time. That way you minimize the risk of damage to the board. And this isn't a complicated board. I mean, you could repair it if you needed to, but I'd prefer to just get it off and be done. So get a little solder ball on there, then find something to start prying it up with. Dental pick, razor blade, however you want to do it. Just make sure you can get in there and get underneath it to start lifting it. And just take your time. Heat one side, lift it a little bit, heat the other side. Once you get one side broke free, then it comes right off. Then you can clean the pads and there we go. So that way we didn't lift any traces and we don't have to worry about any long-term damage. Yeah, okay, it took another minute or so. Yeah, you probably could have twisted it off and you might have got lucky, but why? Why bother? Especially if it's not your stuff. I only have one RCX and I don't want to have to give it away because I ruined somebody's board. I am going to be replacing the solder with leaded solder. I don't know how hot these things get inside, but definitely helps with any sort of cracking in cold joints. Plus, that's all I really use anyways. I do have lead free, but last time I checked, like, unless you take this thing completely apart, you're not going to be able to chew on it and get any lead contamination. So to clean up the electrolyte, I'm just using a little isopropyl alcohol. And you want to be kind of careful on the pads where the buttons go. You don't want to get too much pressure and rubbing on there. You want to make sure you get the board clean, but we don't want to take the coating off of those pads. And you can see that there's some gunk in there. Some of that's from the pads. They do have some sort of carbon coating on them. So just be gentle, you know. You want to make sure you get them clean, but you don't want to clean them so much to where you're doing damage to them. The pads where the traces are, go crazy. You can hit those as hard as you want. We want to get as much of the electrolyte out as we can. And I'm even going to scrape a little bit of the solder mask off so I can get down in there and check and make sure that the connections are still good. Now I am going to clean this entire board because there's electrolyte, you know, all over this area up here. There's no components on here really that are at risk of being damaged by alcohol. I wouldn't use anything other than alcohol. Don't use like Flux Off or any of those chemicals, because some of the plastic on the packages could be eaten away. So any flux residues you want to get off. Anywhere where you think there's some damage, you know, you want to clean the pads real good. And since this is enclosed, I'm going to use my scratch pen, and anywhere where there was some damage, I'm just going to go over the top of it and just scrape some of that away. And what I'm doing there is that I'm just ensuring that any of the corroded spots are 100% cleaned. So you'll take a little bit of the solder mask off, but any kind of caked on electrolyte is not going to be there anymore. So you can see that the pads were nasty before, and let's have a look at them now. And that little bit of solder mask that's gone, that ain't going to hurt nothing. So you can see now, you can see the pads are clean. There's clean copper going to them. There's no more corrosion. Inside the holes there might be a little bit. It's kind of hard to get in there. You can try and take a brush bristle and kind of poke it through just to see if you can get some of it out. But inside the hole it doesn't really matter too much. It's the external where you have to worry. So I'm pretty happy with that. It looks clean. I'm gonna check and make sure there's no breaks in the traces. I want to make sure that point A to point B we have solid connections. I'm gonna pull out my favorite cheap meter, my Radio Shack Special. And we're just going to check for continuity along the traces. And I'm just going to check from the hole to the little spot of bare copper on there. This first one might have a break. So I'm going to clean that a little more. And it ain't gonna hurt it if you expose the copper. It's not doing any damage at all. I want to make sure that we have connections, and if we don't, we need to repair those connections. And it's looking like there is some trace damage from the corrosion. So the first trace is okay. Second trace is not, so there's a physical break there. And I'll show you where that physical break is, and I'll show you how I'm gonna repair it. So I need to keep scraping the mask off. I want to check these other ones. So the corrosion did eat through one of the traces. Let's see if we can get that on video. So that's probably why one of the functions is not working. So alright, it turned out to be a little more interesting repair video than I thought it would be. So that's good. That's kind of cool. So we're gonna look. Get my little stick here. You can see right there. There's the hole going through the board. And there's the trace. And you can see right there where it got eaten away by the, whatever that fluid was that's on there. So we got to make sure that this guy gets connected back to that. And it should be back in business. I have some micro eyelets. I don't know if they're that small. I might just have to use a little piece of wire and rebuild that. I don't think I have an eyelet that small. I can use a surface mount pad too. I might have a pad that'll fit in that small area. There's some corrosion up here too. Just going to keep checking anywhere where it appears to be bad. Make sure it hasn't eaten through the trace. You can try and find where it, where it goes through the board and connects to the other side. But it appears like this one spot right here is our main issue. The through hole that's close to that looks a little questionable, so I'm going to check board to board on both sides, make sure that it's connected on the other side. So I'm going to clean this off real good, expose some of the copper. Just so I can have a look and see how. So the other side looks good. I don't think there's any physical damage on there. Anywhere I expose the copper to, I'm going to cover with a thin solder film. So I'm going to check through the board now and see if the connections are still good through the board. So we have 4 connections there. We'll start with the lower left. Let me zoom out a little bit so you can see what I'm doing here. So I'm just checking these traces and making sure they go through the board. So that one's good. The broken one. The broken one does go through the board. And we have 2 over here. That one is good. And that one's good. So all of our connections are being made through the board. These guys over here look okay. They don't look great, but I think they're still making connections. So we have one little spot we have to touch up. So let's get that touched up. I might have a micro trace in my trace kit. I will see. If not, I can use a small piece of wire. I don't really like using wire because it's just really hard to work with tiny thin strands of wire that are that small. But let's see what we got. I do have some really small ones. I might just use a trace tail because I don't have any rounds that are that small. Let's see. Sees what I got in here. Well, let's try using a bigger one. I'd rather use a trace that has an eyelet in it. And the reason is because I can center solder it. And I know that if I solder into the center that it's going to guarantee me a good connection. And, there's nothing worse than an intermittent connection. So I have this small little guy right there, which nobody will be able to see, but I can see it. And you'll see it in a minute when I cut it out. I really need to find my tweezers. There we go. Right where I left them, under the desk where they fell yesterday. Alright, so I have a small eyelet on a small trace. So I'm going to cut that out. And we're going to try and use that to fix it. And this is a really, really old trace kit. They were actually throwing it out at work, and I said, no, I will take that. I need that. I must have it. And they gave it to me, so that was kind of cool. So since this is microscopic in size, and I don't want to lose it because I don't know if I have another one, I'm going to use a piece of tape that my lovely dog has chewed up the edge of the roll, so every inch it breaks off. And I'm just going to catch it with the tape. That way it makes it a little easier to pick up and I don't lose it. And you'll see how small this is in a second. I'll get the magnifying glass. Alright, let's zoom in. So I'm zoomed all the way in. So my scratched magnifying glass is not good. There we go. So you can see there's the replacement just sitting on the board. And it's a little bit bigger than the original, but we should be able to fit it in there, get it soldered on, and restore that connection. We got to make sure we don't short it out to this guy over here. But I think we should be in good shape. So I'm going to tin all those pads first. And the way I'm going to do that is just put a little bit of flux on them. And I'm going to hit them with the solder. And I'm just dragging a solder ball across them. That's all I'm doing. It doesn't have to be perfect. Doesn't have to be flat. We just want to make sure that they're protected. With a little bit of a coating. Doesn't need to be crazy. Now for our trace. Actually, I'm going to clean that first. And I know this is hard to see. I don't have a good macro zoom setting. So clean off the flux residue. And then I'm going to take a dental pick. And I'm going to use that to align it with the hole. And watch it go flying off the table. Let's try that again. This is why you need tape, because I can't even pick it up with tweezers. It's so small. Alright. Come on. I can't get it back on the board. Doesn't want to be installed. Alright, there we go. So I'm going to, like I said, I'm going to use the pointed end, and you know, a sewing needle would work too. You don't have to use a dental pick. Just something pointy to hold it in place. And all we're doing with that is keeping it centered. I want to make sure that it's centered and it's not touching the other trace. And I'm just going to go over the top of it, heat it, and do a little push. That is it. Now under magnification I can see that it is not short it out. Yeah, I tell you what, I'm looking at this other trace here. It looks like half of the through hole is gone. And I don't like that. So I'm actually going to change my strategy. Since I'm missing part of the through hole, I think I'm going to wire it. And the reason is because I want to make sure that the connection is solid between the top and the bottom. And I know I just said I don't like using wire, but this is one of those cases where I think you have to. I don't know if I'm going to be able to get through. So these holes are not filled. Or at least they weren't filled at the factory. They could be filled now. But the one that I'm right next to the one I'm working on. Let's see if I can show you guys. This one right here only has half of the pad. And I can fix this one and make it really nice, but this one still only has half the pad, and I don't know how long that half pad's going to last. So what I'm going to do is I'm going to take a little piece of wire, I'm going to go through the hole to the other side and actually make a complete connection. If I can get through. My solder sucker is still heated up, so I'm going to try and clear these holes as best I can. I don't know how many layers this board is. It looks like a multi-layer board. So I need to be careful of that too. It's a little bit thicker than a standard board, so I'm going to guess it's probably like a 4 or 6 layer board. The trick is going to be to see if I can get a piece of wire through there. I really don't want to mess around with drilling holes down through there if I don't have to. I can see through the board and all the spots where they go through. And where those through holes are, I can see through the board, so I know they go directly through. I don't know if they're connected to anything else. So let's see what I can jam through there. Small piece of wire is preferred. I don't think I have a drill bit that small. I know I do at work, but I don't think I have one here. These capacitor leads are almost small enough. Let's see if I got a little small through-hole resistor lead might work. One of those really tiny baby resistors. If I have one. I just need something to clear the hole out of any gunk that's in there. I don't really care about the connection. Let's see what I got. I'm just digging through my resistor book. Nothing super fancy about this. Just looking to see if I got an old 1/8 watt micro resistor. And it doesn't look like I do, but I do have some small caps that might work. See if one of these will poke through there. It seems to be kind of small and delicate, so just a little small capacitor lead. It is close. You don't want to be too aggressive with it, because you'll actually damage the through hole. So I'm not going to force it in there. And this is a little bit too big. It doesn't go in any of the other holes. So next step is going to be to try a piece of magnet wire. And that's probably what I'm going to use to do the repair anyways. I have a few different thicknesses of that. I want to find the one that's, closest to the hole size but still fits in there freely. So give me a second while I go get those. So I don't know what gauge this is. Gauge small. I have a bunch of different sizes. This one's just not labeled. But it seems like it would be about the right size. Yeah, and it fits through the other holes. So I'm just going to kind of carefully work that through and try to clean out these holes. And I might not be able to get them through since I did run some solder over them, and that's okay. I need to burn off the insulation. What I'll do is I'll heat it up and I'll just solder them through. First thing you gotta do is burn off the insulation. I don't need to be zoomed in for this. So I have a cheap little micro torch. Heat it up till it gets red hot. I don't know if you can see that on camera. Well, I can see it here, but heat it up till it's red hot. When it's red hot, you know that all the contaminants have been burned off. And then it needs to be cleaned. And I need to go grab a piece of sandpaper, so I will be back again. Alright, hopefully we have everything we need now. So, we burned off the insulation. I have some 600 grit sandpaper, and I'm going to just pinch the wire in there and clean it. And you just want to clean off the soot and oxidation. You know, just put the wire in there, pull it through, do that, 20 times, every different angle that you can, you think you can get, to make sure that you get it nice and clean. And I know you can't really tell, but you have clean copper here and then coated copper back here on the wire. So hole number 1 was able to clear. So what I'm going to do is just put a little piece in there and then snip it. And it's okay if you snip it a little longer than you need. And I'm going to fold it over on the top side. Try to hold it in the place where it goes, and then fold it over on the other side. It doesn't have to be perfect. We're only going to tack down one side. And we don't need it to be full length. We just need it to connect to the trace. So I'm going to trim it. And when you trim it, 45-degree angle, so you get a nice clean cut. Don't push too hard. You don't want to damage the other traces as you're cutting through. But that should be good. So now we're gonna put a drop of flux on there, and you'll only solder one side at a time. So we want to get it, and I'm using my fingernail here. I just want to try and get it tacked in place. If you have to add a little bit of solder, okay, but you don't want to add too much because you might bridge the gap. Just a little bit, just enough to hold it in place. And you'll feel it when it's on there. It won't move. So we're good now. It's tacked in place. Check it to make sure that it's centered. Looks beautiful. Now we're going to go to the other side. And we'll tack this side, and once this side is tacked, then we'll solder it in place. We'll make sure that we got it on the trace, lined up where it needs to go. And since it's such a small wire, it's going to move fairly easily, so you don't have to put too much into it. But get it centered as best you can. Make sure it's straight with the magnifying glass. I like the way that looks. We're going to flux it, and now we're going to solder it all the way in. And I'm actually going to change my tip because I need a little more control. And I'll show you what this looks like after I get it soldered in. So I'm actually going to put the iron on the far side of the trace, and I'm going to feed the solder through. That looks really good. The hole didn't fill though, so I'm going to go back and try to fill that hole. Alright, it filled that time. So I'm happy with that connection. Now I'm going to go back over to the top. Make sure it didn't move. Make sure that still looks good. Again, I don't really like using wires, but I wasn't happy with that repair as a long-term repair. It did not meet my standards. Plenty of flux when you're doing these smaller areas here, because the solder will tend to want to connect to its neighbors. I'm happy with that. The hole is filled. The back side, it's not perfectly straight, but it's close. So I'll see if I can zoom in and show you what this looks like. And this might be a little OCD for this type of repair, but you know what? It'll be a good quality repair. So that's what we got. You can see the wire coming through. Where's my stick? There we go. You can see the wire coming through the hole right there. And it lines up with the trace and continues that connection through the board. It's not filling inside the hole, but that's okay. It's soldered in place really good, and it's not going to go anywhere. And then on the other side, you can see the same thing. That side the hole did fill, and it's on the trace. So we have this one with the brake to do next, and then we can get back to cleaning the board and putting the caps back on. Well, that one was giving me a little problems. So what I'm going to do is I'm going to cut this wire a little bit longer. I'm going to try and use this wire like a drill bit. And I might be able to get it through, I might not. I don't know if it's soldered through on the other side. It doesn't look like it did, but I'm just going to put it in there and try to twist it through. It doesn't seem to want to go through. I can try heat. Can try heating it up with some solder and popping it through. It doesn't look soldered on the other side. It just looks like it's clogged with some gunk. Corrosion. I don't have a small... I could go grab a sewing needle. I might actually go do that. I have... a small little point here, a little awl. That's pretty sharp, but I don't know if that's enough to poke through. We can try. It seemed to poke a little bit. Let's try from the back side. It's definitely got some junk inside there. And I think that's what's fighting me, is the little bit of corrosion that's down in that hole. A little force on it. The other thing you can do is take a pair of pliers and see if you can force it through with a pair of pliers. Get up really close to the board. There's just, since it's copper, it just doesn't have a lot of strength. I have micro drill bits, but I don't think I have anything that small. That's really small. But we got to get that cleared out. Drilling it's going to be an absolute last resort. Sewing needle might I'm pretty close to halfway through. Let's see if I can push a capacitor leg. Capacitor legs are steel. It's starting, but it doesn't want to go through. It's going to take our time and see if we can get it to go. I really don't want to force it, and I want to try not to drill it, because if it is connected to an internal layer and we drill it, we're going to be in trouble. Can try some heat and solder and see if we can just poke it through. Sometimes that works with a little bit of flux. Sometimes that makes it worse. I guess we're going to find out. Yeah, heat is not doing the trick. Well, I'm going to go see if I can find a really small sewing needle and see if I can poke that through. So I will be back in a minute. Alright. So, let's see what we got here. I grabbed 3 different needles. They're all pretty small. I don't know if they'll be small enough. But let's see what we can do. We gotta get something through this hole. I don't think there's solder in it. I just think it's clogged with junk. And the needle does go in a fair amount. I'm starting to be able to see through it. We're getting there. So we just got to keep working it. Again, this is way better than drilling. Let's see if we can get our wire through there now. So close. Not yet. A little bit more. So we'll keep working our needle through. Again, the needle's slightly larger than the hole we need, but since the tip has a nice taper on it, it's going a decent amount into the hole, so we should be able to kind of work that junk out of there. It's not solder. I think we're there. If not, we're very, very close. The wire's even getting stuck in it, so. We are almost there. A little bit more. But sometimes this is what you gotta do. Like, it's a pain in the butt. But I'm just taking the needle and just kind of poking and twisting and I can see through the hole. So the hole is there. I just can't get the wire to go through it yet. There it is. I got it. So now what I'm going to do is I'm going to get the wire pulled through. And then I'm going to like work it in and out a little bit. Kind of try and clear it out a little more of whatever's in there. So our wire's through. Wasn't the easiest thing to do, but we got it in. And now the same thing. Find a clean section of the copper. I'm going to fold it over. Make sure that it's nice and straight. Then I'm going to cut it. And we're going to tack to one side. And I apologize that it's still is difficult to see, but trust me, it's difficult for me to see too. This stuff is small. Alright. There is a bridge we gotta fix. And I apologize for my head being in there, but I really gotta make sure that these are clean joints. So the one side is good, and that one I just soldered in. This one I'm gonna guide along the broken trace. Snip them. And I'll do a close-up under the magnifying glass to show everybody what the repair looks like. After I get it all cleaned up. Let me get this one soldered in and check it. Make sure the connection is good. Alright, successful repair. Now I gotta finish coating the exposed copper on this side. Just use a little bit of wick to make sure it's good and flat. No other reason. I'm going to switch over to my thicker tip. Drag that wick across. And repair should be done. At least the damage part of it. I always put my tips in sideways. So I'm just flattening this area out right here where it's humped up a little bit. It's not really necessary, but it bothers me. I think it makes for a neater looking repair when you don't have just mountains of solder everywhere where it's not supposed to be. Alright. Good enough. Nobody's going to see this anyways. So we fixed the broken trace. We repaired a questionable trace. And now we're going to clean, just spot clean. So we can do a little inspection and then we'll do a full clean of the board. So here's side one. can see these are the two good traces here and here. There's the first one that I repaired here, and the second one. And it looks like it's shorted there, but I looked really good, and it's not. It's just the angle of the camera is on a slant, so there are no shorts. And I'll eyeball it again to make sure. Yeah, those are nice clean joints at my angle. Since the camera is skewed above me, it looks like it's shorted, but here's the other side here. So those two, and I guess if I twisted the board to match the camera, you can see they're dead nuts in the center and good clean repairs. So that part is done. I am going to give the board a light spray with some alcohol, and I'm going to hit it with my little brush here. I'm going to do that off the camera, but I'm just doing that to get any leftover electrolytic fluid off the board. So give me a second to do that, and then we will get into soldering the caps back on. It's okay to be a little liberal with the alcohol. It's not going to hurt nothing. We just want to make sure that any electrolyte that's contaminating anything else is handled. So you just give it a spray, brush it down a little bit, and then I'll give it another spray for a rinse, and then I'll hit it with the hot air to blow any sort of nastiness off. You just kind of, lightly scrub the surface. You don't have to go crazy with it. Just enough to get any junk off that's on there. Kill any coronavirus that's on the board. That's what you got to do. All right. So the board has been alcoholed. And I'm just hitting it with a little hot air just to help it evaporate. I don't want it to evaporate too slowly on the board because then it'll condense. That's interesting. It looks like there's a battery on here too. A backup battery. I'm going to have to check that and see if that battery's any good. So you can see there's some residue on there. And that residue is from, fluid that's been left over on the board. You can see this diode right here had some gunk on it. So I'm going to go through and I'm going to spot clean those. You don't have to have the whole board, perfectly clean. You just need the contacts to be clean where those are. And the residue that's on there, it's a very light film. That ain't going to hurt nothing. Just where we're going to solder, just clean it up a little bit. I'm going to invest in an ultrasonic cleaner. That's on my wish list, so then I can dunk these in there and, with the electronic cleaning fluid, and they'll come out real nice. But for right now, I don't have that, so I got to make do with what I got. I think on this diode over here, this is battery acid. This isn't leaked capacitor. I didn't know these had a backup battery on them though, so we're gonna get in there and check that. And this is just a cheap chip brush. I just cut the brush down so it's a little more aggressive. Works really good. We'll check that diode. Diode is probably good. But just in case, we'll check it. And it looks good. 0.5 volt over a diode is generally a good diode. Give the screen a little clean just because we have it out. Get 20 years of fingerprints off of it. Finger scum. Alright. Nice clean Rcx board. Now I did find there's a battery in here. We're going to check that out really quick before I go back to soldering these caps. There's a backup battery and it's right underneath the screen. At least I think it's a backup battery. That might be the speaker. Hard to tell. It looks like a backup battery to me. We're going to see if it has any voltage in it. If not, it's probably, and we'll check it in reverse. So, okay, that's a speaker. That's not a battery. Not sure why they didn't put a backup battery on these. That would have been nice, but oh well. Alright, let's get into the recap and finish this up. So I got Rubicon caps to replace the Nichicons. The Nichicons are good caps, but a couple of them were bulged and leaking. Caps are really only rated for like 2,000 to 5,000 hours at the most. So I would say we got a decent life out of them. Yeah, I just noticed they did not mark the polarity on here. How fun is that? Okay, that's going to make it fun. Let's see if we can check it with the diode. So I am going to take a wild guess that why wouldn't they mark the polarity of the capacitors? That's craziness. This has to be the positive plane. And this looks more like a ground plane. I don't understand that one, I'll be honest with you. And I didn't even pay attention to it. Well, let's jump on Google and let's look up a picture of an RCX. All we need is one stripe and we'll be able to figure it out. That's a first for me. I'm used to seeing markings on the boards. Lego RCX, inside and out. Orion Robotics. They show one side of the board, but not the other. How nice of them. Let's try again. So yeah, I'm just trying to find which direction the new caps go. I did not anticipate the board not being marked, and I'm so used to having the board marked that I didn't even bother to look. So there's pictures though. We'll figure it out. It's not going to be too difficult, and then I'll make sure that it's documented here so everybody else knows. Alright, here we go. With the board facing this way, like this, all of the lines face up. So the top plane is the negative plane. I would have had that wrong. Yeah, all the lines face up. And on the surface mount one, it goes this way. That is odd to me. I've never seen a board that... Actually, this board doesn't even have designators marked on it. So the diodes and resistors and all that, none of that's marked. Interesting. Like, every other board that I've ever seen has markings on it. R1, R2. They must have been trying to keep this top secret. And then they released all the documents anyways to the public. So I'm just going to go ahead and pop all these in. Now the one that's twisted goes this way. That way. This guy up on the top here goes that way. Let's see, 1, 2, 3, 4, I'm one short. And the last one faces up like all the rest of them. Now when the guy made the circuit board here, tell me why he made all of them facing up except for one. To me that's a layout mistake. I would not have laid the board out that way. They would have all been facing up for me. Personal preference maybe, but to me it just makes more sense. Why would you have 5 of them facing one direction and one not? So here we go. Let's solder them in. You know, making sure the board gets a little bit of heat. I'm not cranking it too hot, but I want to make sure I get a nice fillet under each of these. It's got to be factory or better. I don't bend leads. The original ones were bent a little bit to hold them in place. I don't do that. I hate it. In 50 years, when somebody repairs this board again, like they'll thank me for not bending these leads. There's really not a lot that can fail on these boards. The semiconductors really won't fail. The only thing that's really at risk of wearing out are the capacitors. And really, they're only at risk of wearing out if you use it with the AC adapter. If you don't use the AC adapter, these never go bad. Those are just there to smooth out the power after you plug it into AC. It goes through a diode bridge made of discrete diodes, which I will show you in a second. So yeah, the AC power comes in through here. Then it gets rectified by, I'm guessing, these 4 diodes here. And then these capacitors are all to smooth out that power. So the only chance of these going bad is if you run it off of AC. And I'm guessing if the adapter's putting out more voltage than it should, that'll wear them out a little bit faster. But we used good caps, good quality caps, so I'm not worried about them dying. Don't buy capacitors on Amazon and don't buy capacitors on eBay. That's my tip of the day. Go to DigiKey, go to Mauser, go to Arrow, go to any of the reputable suppliers that sell these things, and you won't have any issues. Alright, surface mount time. The easiest way to get these surface mounts down is to solder one pad, then get it as centered as you can center it, and then heat that pad and drop it in. I don't like to use hot air if I don't have to. Hot air has its place, but I find that it actually does a lot more damage to boards than just plain old solder. So, alright, that guy's in. He ain't going nowhere. Repair's complete. I'm going to go throw it back in the body. You know, it powered on and everything beforehand, so I'm not worried about that. These two buttons were not functioning. After doing the trace repairs, I think we should be fine. I mean, the traces both look good. I don't know how well you can see that, but I mean, they're all connected back to normal again. Back side, same thing. Those are all connected and running where they're supposed to run. So, a couple little pieces of magnet wire, a couple of new capacitors, and I think we're back in business. I'm going to clean off the little bit of flux residue from the back and pop this bad boy in, and hopefully it'll be repaired. So, I know this is not typically what I do here, but you know, I appreciate you guys tuning in or watching this. You know, whoever watches it in the future, you know, feel free to throw some comments or questions down in the box. Like I said earlier, I wanted to do an amp repair and finish the JBL amp tonight, but I'm short 2 parts, so we'll have to do that probably early next week. I don't think I'll be able to get parts here by Saturday, so that one remains on hold, and tomorrow we'll have to dig into another new project. So thanks for tuning in. I'm going to clean this up and test it out. Hopefully it'll work, and then I'm going to share this video with the owner. And until next time, I will see you guys then. Have a good night.